Math 3 Lesson Summary Video, Statistical Reasoning. This lesson is a develop understanding task, which is meant to introduce you to a concept, but not necessarily finalize rules or strategies. The purpose of this task is to understand and identify the characteristics of a well-designed experiment. In the previous units, you learned how mathematical statements can be proved using algebraic and geometric reasoning. This is called deductive reasoning. It involves showing that the conclusion follows logically from definitions, accepted postulates or properties, and theorems. If the reasoning was correct, you could be certain about the truth of the conclusion. We all know life is rarely logical. Real problems that involve data also involve variability, randomness, or incomplete information. This means that you can never be completely certain that you have come to the correct conclusion. This is when statistical reasoning can help you come to a reasonable conclusion, backed by convincing evidence. Statistical reasoning involves formulating a question that can be answered with data, collecting data, displaying and summarizing the data, interpreting the results, and generalizing. To do this, we often have to design an experiment. An experiment will follow specific steps or processes called protocols to make sure that data gathered has the same circumstances. In an experiment, the conditions you want to compare are called the treatments. The response variable of an experiment is the outcome that you are actually measuring. It is important that this outcome is measurable, or you will have no data. In a typical experiment, two or more treatments are randomly assigned to an available group of people, or animals, plants, objects, called subjects. The purpose of an experiment is to establish cause and effect. Does one treatment cause a different response than the other treatment? There are three characteristics of a well-designed experiment. The first is random assignment. This means that the subjects in the experiment each have an equal chance to be assigned either treatment. By having treatments assigned randomly, you reduce the risk of having bias creep into the process. The second characteristic is sufficient number of subjects. This comes from the law of large numbers. You may remember this law from studying probability in Math 2. The law says that the average of the results obtained from a large number of trials should be close to the actual value, and will tend to become closer to that actual value as more trials are performed. This is not a single set number that should always be used, but does imply that more is always better. The final characteristic is that an experiment should use a comparison or control group. You cannot tell if a treatment has produced a different outcome if there is nothing to compare it to. What would it be different from? There are two ways to do this. If your experiment is trying to compare two or more different procedures or treatments, you can split your subjects up among those treatments and compare. If you only have one procedure or treatment that you are testing, you can divide your subjects into two groups, one that receives the treatment and one that receives nothing. This way, you can at least compare the outcomes of the treatment to the outcomes of doing nothing.